So upon power up, the ESP32 is going to act as an access point for the server. So I'm currently connected to the ESP32 on my laptop. We're going to use the IP address from the serial communication during testing. This web page, we're going to enter the SSID and password of the hotspot. Once it's connected to the Wi-Fi network, it's going to send HTML files for initialization to an IP address. The first web page is going to initialize the value of the soil moisture when the soil moisture sensor is dry. I'm going to hang it in the air and then hit OK. Once it's submitted, I'm going to re-enter the IP address, and it's going to prompt the user to hold the moisture sensor in water to initialize the soil moisture while the sensor is wet. The final initialization webpage, in which the user is prompted to enter the soil moisture threshold, the maximum time of sunlight, the sampling period, and the watering duration. I'm going to re-enter the IP address, and I can check the sensor values, which includes the dry and wet soil moisture value and the current soil moisture value.
Hello, this is the water level sensor. It is used to see whether our tank needs to be filled with water for the project. It uses two wires. One of them is going to ground, and the other one is going to be connected to a GPIO pin on the ESP32. When it is like this, that means that there's enough water. You see how the little flap there is floating. And then when there's no water, it's going to send a signal to the ESP board. And as you can see, when the flow is, when there's presence of water, it's 0, and then when there's no water, it shows water levels low, which is 1. This right here is our BH1750 light sensor. It is going to be used to measure the lux value for our project. It uses, we're using 4 lines right now. We're using VCC, SCL, and the SDA and the ground. The adder wire is also connected to the ground. Currently, we have a value for the light sensor at 86, and now we will measure it using a flashlight to see the lux value difference. And as you can see, the value went from an 86 to a 12,715, demonstrating more sunlight.
So now we're going to demo the pump in action. The battery is charged, currently at 7.58 volts, and the soil moisture sensor is dry, so that it is above the threshold to drive the pump, which is, the threshold is calculated using the dry and wet soil moisture values. And we also know that the water level sensor is open, indicating that the water level is not low. So at this state, with these conditions, the ESP32 is going to supply 3.3 volts to the transistor, which activates and allows current to flow to the pump, which pumps water from the cup to the green tub. So we'll press OK.
We have a 2S battery pack with two 3.6 volt batteries supplying the system. I have it hooked up to right here, which is our test boost converter, which is supplying a 12 volt rail. And then I also have a 2S battery pack supplying a buck converter, providing a 5 volt rail for our ESP32 and our other sensors. We also have right here a GPIO pin, which is allowing for our system to calculate the battery level, which is currently displaying a 7.64 volts level, and I'm going to measure it at 7.59.
We can see that we currently have data from the ESP32, but right now it's all zeros. So, and if we go, since our web server is running locally, we can see here the logs from the web server, and it's constantly receiving zeroed out data from the ESP. We can actually update this data though. If we just run this curl command here, we can see that the ESP is updated. And if we go over here, we can see that it actually goes through the web server to update the ESP. So no need to configure the ESP's IP or anything like that manually. You can just go and the web server will automatically take care of that. And the ESP will now send that updated data to the web server, which if we refresh, we can see that it's properly updating our data.